Alright, good day. Welcome once again. It's Ishala Adedeji Michael, and it is Success Enlightenment. Alright, today we want to look at this question. So, let's first analyze our question. It's an application of differentiation. So, the first thing we are going to do today is analyze the question. Then we proceed with the solution. Now, we look at what we are given. We are given the demand function for two related products. I look at this Q1, Q2. It means we have two products, 1 and 2. If you have two products, 1 and 2, then you have the quantity demanded for product 1 will be Q1, and the quantity demanded for product 2 will be what? Q2. Alright, as stated here, the prices of product 1 is P1, and the prices of product 2 is what? Is P2. That's what we are given. From the question we are given, they said the two products are related. So with the fact that these products are related, it shows that these two products, they are either what? Competitive demanded, or what? Complementary demand. That is, they are jointly demanded or competitively demanded. That is, they are either competitively demanded or jointly demanded. Alright, so how do we know if they are competitively demanded and if they are what? Jointly demanded? If a product is competitively demanded with another product, it means that what? The relationship between that product and the prices of the other product will be what? It will be positive. That is, when the price of the other product is what? Is going up. When the price of the other product is going up, the demand for that product will be what? Will be increasing. So when we look at the demand function we are given here, we are given Q1. This is Q1. When you look at the price of P2, now this is a negative. This is negatively related. It shows that when the price of P2 is increasing, the demand here is what? Is decreasing. So therefore, the relationship between them is not what? It's not competitive. So therefore, it is what? It is jointly demanded, because when two products are what? Jointly demanded. That is, the relationship between the two products is what? Is jointly. It means the two products are needed together. So when the price of one of the products is what? Is increasing, so the quantity of the other product is what? Is decreasing. While when the price of one product is what? Is decreasing, the quantity of the other product is what? Is increasing. So here it's what? It's negative. So when we look at what we have here, it is negative, and what we have here is negative. It means what? Product 1 and 2. Product 1 and 2 are what? Are either jointly demanded or complementarily demanded. They mean the same thing. So we've already established the nature of the demand for the two products. Now let's get to what we have to find. We're given the demand function already, the Q1 and the Q2. So we have to find the prices the manufacturer will charge on each product to maximize total revenue on the sales of the two products. Now, as a producer, as a firm, the primary motive is to what? Is to maximize your revenue. You want to get the most of your cost of production. You want to get the highest profit. So now we have to find the price, which is the P1 and what? P2, the price that we charge for goods 1 and the price that we charge for what? Goods 2, for the what? To maximize total revenue. And also we have to find the expected demand of the product. That is, at this price that the seller or the manufacturer maximize his total revenue, what is the quantity it needs? What's the quantity it needs to maximize total revenue? So which means, what is our Q1 at this maximizing price P1, and what's our Q2 at this maximizing price P2? That is all we are asked to find. Okay, so we'll be going here from the question analysis. Now we'll be going to the solution to this question. All right, now that we have an understanding of what the information given is, we have an understanding of what this is. It's a firm, a manufacturer, having two products, and they want to maximize total revenue, and is having the demand function for the two products. So to solve this question, let's first state what is given. What is the demand function for Q1? So demand function for Q1 equals to 450 50 minus 4P1 minus P2. Let's name this equation 1. Alright, what's the demand function for Q2? That's 500 minus 2P1 minus 3P2. Let's name this what? Equation 2. Alright, what are we really looking for? We are looking for the what? Price at which the firm maximize total revenue. So before we can look at the price a firm maximize total revenue, we have to at first know the firm total revenue, right? So here we have to look for what? Total revenue. That is, what is the firm total revenue? Alright, what is the firm total revenue? Alright, now the firm total revenue, you will agree with me, is equals to what? The total revenue the firm make from what? From the sales of what? Commodity 1 plus the revenue the firm make from the sales of what? Commodity 2. So therefore we have to look for the firm revenue for commodity 1. Alright, the firm revenue for commodity 1, let's name this as what? R1. Let R1 be the firm revenue for commodity 1. Don't forget, your revenue is price times quantity. So therefore the revenue for commodity 1 will be what? R1 P1 Q1. That is, R1 equals to what? P1 times Q1. The total revenue for commodity 1 is equals to what? Price of commodity 1 times the quantity of commodity 1 that is sold. So what about for commodity 2? The revenue for commodity 2 equals to what? R2. So the revenue for commodity 2 will be what? The price of commodity 2 times what? The quantity of the commodity 2 the firm actually sold. So that will be what? Our P2 Q2. Alright, now we find our what? Revenue for commodity 1, and we have already find our what? Revenue for commodity 2. Okay, now we can now find our what? Our total revenue. Okay, now the total revenue for the firm will be what? R, which equals to what? The revenue for commodity 1 plus what? Revenue for what? Commodity 2. Are we getting it? It's very simple. You are selling 2 products and you are looking for total revenue you make for the sales of 2 products. You are selling battery and television. That is 2 products. So your revenue for battery and your revenue on what? Television adding together gives you what? Your total sum for the what? For the revenue. So that's what we just do there. So don't forget, your revenue for product 1 is already known as P1 Q1, and revenue for product you already know as P2 Q2. So therefore your firm total revenue then can now be what? P1 Q1 plus what? P2 Q2. Okay, alright, this is what? The firm total revenue. Now we can name this what? Equation 3. Alright, we can name this equation 3. But here we can solve this equation 3 further, since we have our value for Q1 and we have our value for Q2. So therefore we can substitute for Q1 and Q2 in what? In equation 3. So therefore substitute for Q1 and Q2 in equation 3. Don't forget, your Q1 is equation 1 and your Q2 is equation 2. So R, which is the revenue, then equals to what? P1 into what's your Q1? Your Q1 is what? Is 450 minus 4P1 minus P2. That's equation 1 plus P2. What's your equation? What's your quantity 2? That is Q2, equation 2. That's 500 minus 2P1 minus 3P2. Alright. So all we do here is just, we are looking for what? P1 Q1 plus P2 Q2. I already have our Q1 and Q2. All we do here is what? We substitute Q1 here, this for Q1 and this for what? Q2, and this is what we have. So all we have to do is just open this bracket, is to expand this bracket. That is to multiply this by P1 and multiply this by P2. So your total revenue R will then be what? 450 P1 minus 4 P1 square minus P1 P2. When you multiply all through by P1 plus 500 P2 minus 2 P1 P2 minus 3 P2 square. Alright, when you multiply everything here by P2, this is what you have. So therefore, all we simply do is what? We collect the like times when we collect the like times here. So our R, which is total revenue function, will then be equals to what? 450 P1 plus 500 P2 minus 4 P1 square minus 4 P1 square minus 3 P2 square minus P1 P2 minus 2 P1 P2. This equals what? Minus 3 P1 P2. Okay, and this will be our revenue function. So there, here we can say our revenue R is a function of what? P1 P2. That is, our revenue is a function of the price of what? Commodity 1 and price of commodity 2, and is equals to what? 450 P1 plus 500 P2 minus 4 P1 square minus 3 P2 square minus 3 P1 P2. Alright, we can name this equation 4. Let's have this as equation 4. This equation 4 is still the same thing as our equation 3. Only thing we do there, what we substitute for Q1 and Q2 in equation 3 to get equation 4. Alright, so from here now, what do we do? From here, what we do is very, very simple. What we do here is that we are having a revenue function, and we are asked to maximize our revenue. When you look at what we have in our revenue, we have price of two commodity, price of commodity 1 and price of commodity 2. This automatically tells us, as a student of mathematical economics, so automatically tells us that we are applying our knowledge of what? Partial derivative. Alright? We are applying our knowledge of what? Partial derivative. So this question require us to what? As an application of what? Partial derivative to economic analysis. So from here, what you do is what? Is you take the first partial derivative of revenue with respect to price of commodity 1, and you take your what? Your partial derivative of revenue against with respect to what? Price of commodity 2. What am I saying? You take the what? First partial derivative with respect to what? P1. You take your what? Again, you take your first partial derivative with respect to what? P2. Alright, that's what we are talking about. Now, if you find the derivative of this with respect to P1, don't forget, when you are finding derivative with respect to P1, it means that P2 is treated as a what? As a constant. So, apply our knowledge of basic differentiation. What do we have? This we turn to what? 450. This will be 0, and this will P2 become a constant. This will be 0. This will be 2 times 4, that is a minus 8P1. This will be 0. This will be what? Minus 3P2. Minus 3P2. Okay? Also, if you find the partial derivative with respect to P2, this will be what? This will be 0. This will then be 500. This in respect to P2. This will be 0. This will be what? Minus 6P2. This will be minus 3P1. Alright, let's call this what? Equation 5, and let's call this what? Equation 6. Alright, what we are doing here now, from our basic knowledge of the application of partial derivative to economic analysis, we have to equate our first partial derivative with respect to P1 to 0. And also we equate our first partial derivative with respect to P2 to what is 0, which is the next step. That is, you equate the first partial derivative to 0 and solve for P1 or P2 simultaneously. Alright, you equate the first partial derivative to 0. That is, this the first partial derivative, these are the first partial derivatives. You equate the two first partial derivatives to 0 and you solve for P1 and P2 simultaneously. When you equate it to 0, what do we get? This will give us 450 minus 8P1 minus 3P squared equals to 0. Let's call this equation 7. Then this will be what? 500 minus 6P2 minus 3P1 equals to 0. Let's call this what? Equation 8. So we can then solve equation 7 and 8 simultaneously to find what? P1 or P2. As I've said, you can solve this equation simultaneously using elimination method. And at the same time, if you've forgotten your knowledge of simultaneous equation, so you can still solve this only by, you can make any one of these price subject of the formula in equation 7 and equation 8. Let's say we're working with equation 7. If you have your understanding of simultaneous equation, you can use it to solve for either P1 or P2. Then you substitute the value back and you find your what? Your P1. If you solve for P2, you substitute value to find your P1. If you solve for P1, substitute value to find your P2. But let's assume that you don't have knowledge of simultaneous equation again. So from here, how can you solve it? You can make P1 solve the formula in equation 1. Let's say in equation 7, rather, make P2 subject of the formula in equation 7. That is, you make P2 subject of equation 7. These are equation 7. So then we have 450 minus 8P1 equals to what? 3P squared. So therefore, our P2 equals to 450 minus 8P1 all divided by 3. Also, at the same time, in equation 8, we can also make P2 subject of the formula. So in equation 8, make P solve for P2 in equation 8. So in equation 8, you want to also make P2 subject of the formula. So here we have what? 500 minus 6P2 minus 3P1 equals to 0. Then here we have 500 minus 3P1 equals to 6P2. So here our P2 equals to what? 500 minus 3P1 divided by 6. Let's call this what? Equation 9, and let's call this what? Equation 10. Now when you look at it, P2 is P2, so it means equation 9 and 10 is equal. So therefore we can equate equation 9 to 10. So equate equation 9 to 10. That is 450 minus 8P1 divided by 3 equals to 500 minus 3P1 divided by 6. Now from here, you can multiply through by 6. Multiply through by 6, this will give us what? 2, 6 into bracket 450 minus 8P1 divided by 3 P1 equals to 6 into bracket 500 minus 3P1 all divided by 6. This we cancel this here 1, this here 2. So what we have left is now 2 into 450 minus 8P1 equals to 500 minus 3P1. So we have 900 minus this 16P1 equals to 500 minus 3P1. Here we can collect the like times. So we'll be having what? 900 minus 500 equals to what? Minus 3P1 plus 16P1. This will give us what? 400 equals to what? 30P1. So therefore, our P1 equals to what? 400 divided by 13. Okay? This is the value of our P1. We put this in decimal form, you'll be having what? 30.777. So we are solving in Naira. We approximately have 30.77. Now we already find our P1. Now we need to find our P2. Now that you have already find your P1, which is the price of commodity 1, so all you have to do now is what? Substitute to find the what? Price of commodity 2. So recall equation 10, we already have our price of commodity 2, so do we in what? In equation 2. So all we are going to do simply here is what? Is to substitute for P1 in either equation 9 or equation 10. Here I'm working with equation 10. So therefore, P2 equals to what? 500 minus 3 into what? 30.77, which is P1 divided by 6. So this will then be what? 500 minus 3 times 30.77 is 92.31 all divided by 6. Then P2 equals to 500 minus 92.31, 407.69 divided by 6, which is then equals to, in Naira, 67.95. This will be our what? Our P1, and this will be our what? Our P2. Now, instead of solving it this way, I solve it this way because out there, if you don't have knowledge of simultaneous equation, you can still go ahead and you still solve this and you still have your P1 and P2 just by what? Making either P1 or P2 subject of the formula in equation 1 or in equation 7, and also make it solid formula in the equation 8. Then you find the value for P2 in equation 7, you find the value for P2 in equation 8. Then P2 equals to P2, you equate the two together. When you equate the two together, you get an expression for P1 and you find the value of P1. Then you substitute that for P1 in equation 10 or 9, then you find your what? P2. You can do it simultaneously and this will be the answer that you are going to get. Now, if you are solving simultaneously, the best approach you use here is you use elimination method. You should use elimination method. Mind you, you can either solve it this way or you apply simultaneous equation. Also, you can use Cramer's rule to solve this question. This you can use Cramer's rule to solve for your P1 and for your P2. If you solve for P1, P2 using simultaneous equation or Cramer's rule, you still get the same answer as P1 equals to 30.77 and P2 equals to 67.95. All right. This is what we are given. We are given this. We find our revenue, and we already find our P1, already find our P2. And the next thing we have to do is to check if this price we have actually found, if it's a maximum profit maximizing price or not. So how do we do that? We take the what? The second partial derivative and the cross partial derivative of our revenue function. So don't forget, we've initially taken the first partial derivative, but we are going to start again. The first partial derivative, which is what? Derivative of R with respect to what? P1, same thing as what? This will be what? 450. This will be 0, since we are having P2 here. This will be minus 8P1. Minus 8P1. This P2, this will be 0. This will be what? Minus 3p2. That's fourth partial derivative. Also, you can take the what second partial derivative with respect to p1 immediately, and that will be what derivative of what revenue with respect to what p1 twice. So here this is what this derivative of this with respect to p1. This will be 0 and this will be what minus 8 and this will be 0. Okay. So also we can take the partial derivative with respect to what p2 with respect to p2. Here this will be 0, this will be the 500, this will be 0, this will be minus 6 p2 minus 6 p2 and this will be minus 3 p1. Alright, immediately you can take the second partial derivative and this will be what derivative square r with respect to what p2 twice, and this will be what this will be 0, this will be minus 6, this will be minus 6. Now this is our what partial derivative. This is second partial derivative. Now when you look at your second partial derivative, this is what minus 8 which is less than 0, this is minus 6 which is less than 0. Automatically this is telling us what we are dealing with what a maximizing price. So this price is a maximizing price. But before we can conclude it is maximizing price, we still need to find what our cross partial derivative. This is not sufficient. Alright, but should in case we solve this and we instead of having less than a figure less than 0, if you have a figure here greater than 0, then it will be a minimizing solution. But if you have a figure that is equal to 0, then it is neither maximizing nor minimizing. So, alright, so let's find our cross partial derivative. How do you find your cross partial derivative? What we are talking of here, we are looking for what? Derivative of what? Square r with respect to p1, p2. That is this here as you have this here. Now the next derivative, instead of finding derivative again with respect to p1, so here we are going to find derivative from here with respect to now to p2. So derivative of this with respect to p2 here, this will be 0, this is 0, and this will be what? Minus 3. Okay, so also the same thing here we have square r now with respect to what? P2, p1. Now we first find the derivative with respect to p2. Now we are finding this now with respect to what? P1, and this will be what? 500. This will be what? This will be minus. This will be 0. This will be 0, and this will be minus 3. Alright, this is minus 3. Now what are we going to do there is we are going to find the determinant of our second partial derivative as well as our cross partial derivative, and the determinant will look like this. Here we are going to have r square p1 square. We are going to have derivative of what? R square with respect to what? P1, P2, and here we are going to have what? Derivative of square R with respect to P2, P1. Here we are going to have the R square. Here with respect to what? P2 square. So we are going to find the determinant. So what is the derivative of R square with respect to P1 square? I think this is it. So we have here what is this? From what you have got, we have this to be minus 8. We have this to be minus 8. This is this. We have this to be what? Minus 3. This is this. We have this to be minus 3. And this is this R squared P2. This is, we have this to be minus 6. So we have to find the determinant of this. Don't forget how you find the determinant of a matrix. You multiply principal diagonal and you what? Subtract it by what? The product of the what? Minor diagonal. So therefore you have minus 8 times minus 6 minus into bracket minus 3 times minus 3. So minus 8 times minus 6, that's it as 8 times 6 minus times minus is plus. That will give you, this will be what? 48 minus 3 times 3, that will be what? That will be minus 3 times 3, that will be 9. So minus 9, minus times minus is plus, and this will be 48 minus 9, and this equals to what? 39. If you look at what you have is greater than 0. What you have is greater than 0. So this means you can find the what? The maximum and the minimum of the given function. Since the determinant of this is greater than 0, and now from the fact that the second partial derivative of revenue with respect to price of commodity 1 is less than 0, and for the fact that the second partial derivative of revenue with respect to price of commodity 2 is what? Is less than 0, then we can conclude that P1, P2 is a what? Is a maximizing price. That is, P1 equals to 30 naira 0.77 kobo, and P2 equals to what? 67.95 kobo, 67 naira 99 kobo. These are the price at which the firm maximize its total revenue. If you look at the process very well, it's very simple. The first thing we try to do is what? We find our what? P1 and P2, then we check. Since we run a check, if this P1 and P2 is a maximizing or minimizing. Now the first thing we do is what? You check this. If this is greater than 0, then you can have maximizing or minimizing. If this is greater than 0. This have to be greater than 0. If this is less than 0 or equals to 0, then you can neither find maximizing nor minimizing. But once this is greater than 0, fine. You can find the maximizing or minimizing of the function of concern. The function we are looking here is the what? Is the revenue function. Revenue as a function of price of commodity 1 and commodity 2. Now this condition is not enough to now decide if it is maximizing or minimizing. So now have to check your what? What is your what? Second partial derivative of revenue with respect to what? P1. If it is what? Less than 0, then you are dealing with the what? A maximizing price. And if it is greater than 0, then it will be a minimizing. That will be reversed the case. Then you check your what? Derivative of revenue with respect to price of commodity 2. Also, second, the other derivative of revenue related to price of commodity 2. If this is also less than 0, then you are dealing with what? A maximizing price. And when you look at it here, it fulfills the condition for maximizing. So therefore, P1 equals to 30.77 naira and P2 equals to 67.95 is a maximizing price. That is, the firm maximize the total revenue or the sales of commodity 1 and 2 when the price of commodity 1 is 30 naira 7 kobo and the price of commodity 2 is 67.37 naira 95 kobo. And this is the solution to the first question we are asked. Now, solving further, they asked us to find the expected demand. The expected demand. So the second part asks us to find the expected demand. What that simply means is we've already concluded that this price and this price is when the revenue is maximized. So what is the price? What is the quantity demanded rather as the price maximizing for P1 and P2? So all you do is what? For Q1, you write this the what? Quantity. So you just have to substitute this for what? P1 and P2 for Q1 and this for P1 and P2 for Q2. So the quantity you find there is the expected demand. So Q1 then will now be equals to what? 450 minus 4 into what? What's our P1? 30.77 rather, minus what's our P2? 67.95. Also for our Q2, we have what? 500 minus 2. What's our P1? 30.77 minus 3. What's our P2? 67.95. Alright, so what we do here is that Q1 equals to, help me with it. Q1 equals to what? 450 minus 4 times 30.77. What do we have? So what we have is minus 123.08 minus 67.95. So our Q1 equals to 450 minus 123.08 minus 7.95. What do we have there? It will be minus 191.03. So Q1 equals to 450 minus 191.03, 258.97. So therefore, the quantity demand for commodity 1 will be 258.97. In some question, they might say the quantity demand is in million, so all you have to do is just put million to it. But for now, in the question, it is not stated the unit it is, so we leave it as 258.97. So do the same thing here. So our Q2 equals to what? 500 minus what is 2 times 30.77? That's 61.54 minus what is 3 times 6795? That will be 203.85. So Q2 equals to 500 minus this 61.54 minus 203.85. What does that give us? 265.39. So Q2 then equals to what? 500 minus 265.39. What does that give us? To 234.61. So that's the unit of Q1 and Q2. Now, there is something very, very important here. All right? What is important? Now, when you are dealing with price, as far as economics is concerned, economic analysis, you can leave price in decimal point. But when it comes to quantity, you cannot leave it in decimal. So you have to round these two up to whole number. Okay? So when you round this up, so your Q1 will then be what? 259. And your Q2 will be equals to what? 235. So the quantity, the expected quantity demand for Q1 is what? Is 259, and the expected quantity demand for commodity 2 is what? Is Q35. So that's the answer to the question, second question. Suppose the question asks further that what is the total revenue? So at the price that the firm maximizes revenue, what's total revenue? All you simply do is what? Here you substitute for P1, P2 in what? In your revenue function. That's all you have to do. And what you find here is your what? Is your total revenue. Suppose the question asks further, what is the marginal revenue of what? Of commodity 1. That is the marginal revenue of what? Of commodity 1. Then this will be what? This. The first partial derivative of this with respect to P1. So what you have here, there you substitute the value of P1 and P2 there. Then if you ask for P2 for commodity 2, that will be the what? The first partial derivative of what? Revenue with respect to what? Commodity 2. Then you substitute the figure you have there will be the what? Marginal revenue for commodity 2. So I believe this is very, very simple. All you have to do from the step 1 is what? Understand your question. Once you have your question understand, then you know what you are looking for. You find your revenue function. Once you find your revenue function, for your revenue function, you find the derivative of revenue function using partial derivative with respect to P1 and P2. So equating that to 0 and solve simultaneously, or rather the way I solve it, I solve for P1 and P2. So by that you find your P1 and P2. Then you have to put it to check. So you use your partial derivative of a second order partial derivative and the cross partial derivative to check if it's really if the minimizing or maximizing function, or if minimizing and maximizing function exists at all, by finding the determinant of the word of the second partial derivative and the cross partial derivative. And once you decide that, once you evaluate if it is maximizing or minimizing function, then you decide what is the price. In this case, the price is a what? Is a maximizing price. It's a maximizing price. Then you find the expected quantity demanded for commodity 1 by substituting P1 and P2 in what? In the demand function for commodity 1. And you find the expected demand for commodity 2 by substituting P1 and P2 for the what? Demand function for commodity 2. And by this we come to the end of the question. I believe it is well understood. Go through it. If you find anywhere that you didn't get clearly, please feel free to engage me. And when I solve simultaneously, I said you can solve it simultaneously. You can use Cramer's rule. I solve for P1 and P2 using knowledge of subject or formula there. That's what I do. Try and solve it in three steps. If you are finding any difficult, feel free to engage me. Thank you for watching. Don't just watch, like and subscribe and comment, and I'm expecting your questions. Thank you.